Okay folks, in another video I showed everybody how I put this pipe in a loop shape on my wood stove, and I warned everybody that you have to be very careful about putting too much of a heat exchange unit on your wood stove, because if you take too much heat out of the smoke, then it doesn't have enough energy left to carry the smoke up the chimney. Well, I've run into a little situation here. I've got enough heat to carry the smoke up, but behind my shop there's a bunch of really tall trees. So what we're going to do is we're going to try to see if we can increase the draw on the chimney by doing something I haven't seen in years, but when I was a young man working in the sheet metal business, we used to make these all the time, and that's what's called an H-cap. Now, anybody that knows anything about sticking a piece of pipe in the air, the higher you get it, of course, the more air is moving, and as air moves across a pipe stuck in the air, you have what's called a venturi action, and it actually causes a vacuum buildup or a minus pressure inside the pipe and gives you a draw, even though that you don't have a fire on it. Now, we used to build these when I was a young man and install them on buildings that had trouble with the draw. We're going to see if it works here, and I'll let you people know. But all you do to make one, real simple, is 3 T's, and you put one on top of your pipe so it goes out to the side. You can see the other one on this left is the other way. Now, to make it draw proper, we need to extend that up. So we're going to put an 8-inch piece of pipe on the top and bottom of each one of the side T's, that one and this one. And that will give us a little bit more length, and hopefully it will cause more draw. We'll find out. But now when you do this, if you do it, okay, just remember one thing. The pipe, you're going to slide this pipe inside of that one. You don't want it straight up and down. You want to put it on a little bit of an angle, just a little bit of an angle like this. The reason being that when it rains, if it's straight, then the rain can actually get inside. If you put it on a little bit of an angle where this part is inside, this part is out, then the water will drip off the top edge and go down in here. It won't go in your pipe. But it doesn't have to be much, 1/8 of an inch, 3/16, quarter, whatever. Just whatever feels good to you. But you put it on a little bit of an angle like this, not straight up and down. Okay? All right, well, we're going to go ahead and finish this up. Justin, my new lab assistant, is over here, and he's a dynamite kid. I mean, dynamite. This kid is so smart, it's unreal. But there he is, Dustin. That's Dustin. All right, people. All right, good deal. Okay, we're going to end this, and I'm going to go ahead and put it on and wait a few days and see how well it works, and make another clip and add it to this one. You people will be great. Bye. There.
Well, I didn't quite understand what the old man meant whenever he said to angle the edges. Well, after getting it together, now I understand. If the rain drops and falls to right here, and the rain collects and runs down the inside here, it may gather on this lip, but it won't fall into the inside of the pipe and drain down your bar here. It'll fall out towards the center and come out to the bottom. So that way you don't need any kind of caps or any kind of vent cap or release for the rain to come in. So there's no worries. We put this at the top and we're good to go.
Okay folks, there it is, all finished, up and running, and you can see both upper stacks are just flowing really good. Now if you watch the bottoms real close, now we don't have hardly, well you can see the smoke going straight up, we don't have hardly any wind at all. But if we had any wind whatsoever, the bottoms would start drawing as well, which shows that the venturi effect is there. In other words, the more openings you have, and with the air passing across them, the more vacuum it actually creates inside of your stovepipe, and giving you a better draw, better draft. Okay, this is just some really old technology. I learned this when I was an apprentice in sheet metal, and there were a lot of people who used these back in the old days. Of course, you know, the old days to me were my young days. Oh, there you go. See the whiff of smoke coming out the bottom? As the wind picks up, it does a lot better. Of course, you need a backdraft damper in your stove so you can control it. But okay, at least you can see it works. Should help with the creosoting. All right, folks, speaking of creosote and so forth building up in your smokestack, I've got a little example here I want to show you. Let me get the camera back here. Dustin's got elbow that some people used, and they burned a lot of green wood. And when you burn green wood, it's not a big problem, but you know, you will have creosote. It's when you bank your fire at night, that's when your creosote builds up. Dustin, move that a little closer to the camera and let the people see inside. It is solid. Look, do you see that? I mean, that is solid and sticky as crazy, but it's totally full. So when you build a heat exchange unit for a wood stove, be careful. Do not build it too good and draw too much heat off of your stovepipe, okay? Otherwise you can have a problem, because this stuff is very combustible. If you get it hot enough, it will burn, and it'll burn like a acetylene torch. A big one. All right, everybody have a great weekend. Bye-bye.